So in these first couple of examples, we're going to look at statements and we're going to decide if they're true or false and provide counter examples. We said a counter example is an example that proves it to not be true. So read the first example. I'll read it with you. An example, if angle ABC and angle CBD form a linear pair, then angle ABC is congruent to angle CBD. So you want to think about, is that always going to be true, or could that be false? The best way to do that with these types of problems is to draw a picture. So start with the first part and ask yourself, what does it mean to be a linear pair? What does that mean? Adjacent and supplementary. So I have A, B, C, and angle CBD. Those two angles form a linear pair, right? Are those two angles congruent? No. I could say that's 30 and that's 150. This is a counter example. So you could draw a picture to make a counter example. It doesn't always have to be in words. It doesn't have to be a number. It could be a picture to show the example. Now, there is a situation where they could be congruent, but I'm trying to prove that the statement is false. So I don't want that. I want this as my answer because it proves that the statement is false. So look at the second problem. See if you can come up with a situation where AB, BC, and AC would be congruent, but not collinear, A, B, and C. So I'll give you a second to think about that. So in this picture, I'm drawing an equilateral triangle. AB, BC, and AC are all congruent, but A, B, and C are not collinear. So you just have to come up with one example. So you do 3 and 4. See if you can come up with a counterexample for these. They could be true, but see if you can come up with a group of time when they're not, and then provide a counterexample. They're not all going to be false. So try that. So number 3, I have the statement, if AB plus BC, so AB plus BC equals AC, and what they're saying is this has to be congruent to that. Well, that's not always the case, because what if AB is 8 and BC is 30? AC equals 11. Is that still a true statement? Yes, but the two are not congruent to each other. Knowing that these two add together to get this does not necessarily mean that the two pieces are congruent to each other. And then our example 4, if angle 1 is complementary to 2, so you're going to ask yourself, what does that mean? Angle 1 plus angle 2 has to equal 90. And angle 1 is complementary to angle 3. And they're saying these two have to be the same value. Well, that's actually true. It's not a false statement. Okay, this one was false, and that's my counterexample. This one is actually a true statement. So we know 3 is the overlapping section. How many students work just after school? 5. How many work weekends? And then how many will do both? So the answer to question 5, how many students work after school and on weekends, what would my answer be? Just 30. How many students work after school or on weekends? So either or. 22. Because I'm not including the section where it overlaps. So I'm looking at, they either do this or they do that, but they don't do both. Okay. On the next section, determine whether the stated conclusion is valid based on the given information. If not, write invalid. Explain your reasoning. So on the notes, you looked at different types of reasoning. You talked about inductive reasoning and deductive reasoning. Deductive was the one that was based on laws and rules and facts. Inductive was the one where you looked at examples, you looked at patterns. Some examples were the weather forecast as an example of inductive reasoning. A science project as an example of inductive reasoning. What we're looking at now is really deductive reasoning. Let's look at number 7. They give me that the sum of the measures of two angles is 180 degrees. Then the angles are supplementary. Is that true or false? It's true. We know by definition, if the sum of the measures is 180 degrees, then the angles are supplementary. So if they give me the very beginning, measure of angle A plus measure of angle B equals 180, what can I say about A and B? That they're supplementary. So this is actually a valid statement. Okay? The fact that A and B are supplementary follows from knowing that the sum of those angles is 180. Alright, let's look at the next example. The sum of the measures of two angles is 90 degrees. Then the angles are complementary. Another thing you took notes on was what the hypothesis was and what the conclusion was. Which was which? The hypothesis came after the if, was in the beginning, and the conclusion came at the end, it was everything after that. So you got it, the sum of the measures of two angles is 90, then the angles are complementary. You tell me angle ABC is 45, and measure of angle DEF is 48. So can I conclude that angle ABC and angle DEF are complementary? No, why not? Yeah, 45 plus 48 does not equal 90, so they can't be complementary. These statements though all have to lead in that direction. They give you something, you have to follow from what they lead with. Let's look at the next example. If the sum of the measures of two angles is 180, then the angles are supplementary. So if they tell me the sum of the measures is 180, then the angles are supplementary. Well, do they tell us angle 1 and 2 are, the sum is 180? If you have to bring in prior information, then you can't really say it's valid. So you've got to read these exactly like they're given to you. You can't pull in this other information that we know. So we know this means they're supplementary, but based on our laws, that doesn't necessarily determine. This doesn't follow directly from this. They would have to say that measure of angle 1 plus measure of angle 2 equals 180 for me to make that conclusion. So there's a whole lot of thought that goes into this that's really the other way around. You almost don't want to think too much when you're doing these problems. And valid, because this doesn't follow from what you gave. So you could just put it valid. Doesn't follow. Just explain some way. Most of the things that I'm going to ask you, I'm going to say, what law are you following? This is just kind of getting us in practice of understanding the different laws. So you have two types of deductive reasoning. You have law of syllogism, and you have law of detachment. Think about what the word detach means. What does that mean? Break away. Okay, detachment, you're going to have a statement. If A, then B. And they're going to give you A so you can conclude B. And it has to go in that order. Syllogism, they're going to give you more than one statement. They're going to give you something like that. It's like you have a connector in the middle. What's connecting A to C? B. So they're going to give you a statement, if A, then B. If B, then C. So your statement would be, if A, then C. This is syllogism. This is detachment. So we're going to look at some different statements and decide, can I use one of those laws to get there? If two angles are complementary, so this is like my A, then the sum of their measures is 90. If the sum of the measures of two angles is 90, then both of the angles are acute. So the way you use law of syllogism is your conclusion then is you take the beginning, the two angles are complementary, and you connect it all the way to the end. They're both the angles are acute. The syllogism is always taking one or two or three, you can have four statements. But the very beginning hypothesis connects to the very end conclusion. So I want to connect the beginning to the end. If the heat wave continues, then energy costs will be higher. Go ahead and look at the next example and see if you can connect the beginning to the end. And every statement does not necessarily have to be an if-then form. So your B part in this statement is Marla Tudor's chemistry. So this allows me just to skip that. I can go directly from if it is Tuesday, but you want to make sure you actually use names, make the sentence make sense. So if it is Tuesday, I'm not going to take off if you put she, but on this, but as we go into this, making sure your sentences make sense is going to be important, and I will sometimes take off. So while it is not an English class, I will take off on grammar. So I to have that clear. So I'm going to put Marla arrives home at 4 instead of just saying she, so I know that who she is. So just because this statement is not put in if-then form, is still saying something about the conclusion of this statement. So I can say, if a marine animal is a starfish, then it lives in the least stable of the oceans. Do y'all feel like you're not in a math class? Okay, these problems I'm going to pick. Am I using detachment or syllogism, and can I make it? Is it a valid conclusion? First number, if a whole number is even, then its square is divisible by 4. So you want to see, are they giving me the hypothesis part of the statement? Hypothesis, conclusion, they're giving me the hypothesis. So my conclusion that I make is the number you are thinking of is what? Is, I'll put, has a square that's divisible by 4, because you got this part too. Then its square is divisible by 4, so you're getting the wrong part of it. So this problem is an example of detachment, because they've given me, if A, and the conclusion is then B, they gave me A, and I concluded B. So this example is using detachment, where I said, we're going to give you a statement, if A then B, you have to say A, and you conclude with B. If A, then B. If B, then C. You want to make sure that they are telling you A. Did they tell you A? So then I conclude